Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 7 of AI Assisted DevOps Zero to Hero series, and in this video, we will focus on AI agents. Although the topic heading says AI agents for DevOps engineers, anybody can watch today's video and build their AI agents. It's going to be a very simple video with demonstration. So we will start with understanding what are AI agents, how are they different from assistants like ChatGPT. We will learn about frameworks, not enterprise tools, but open source frameworks that can help you build AI agents in a very simple way. We'll also learn about the best practices while using agents. And finally, we will build a project where we will develop simple AI agents, not a single agent, multiple agents to implement a complex task. So it's going to be a very interesting video. Make sure you watch it till the end. Also, I will be uploading the complete video notes along with the commands that I'm going to use to the day 7 folder of this GitHub repository. Just start the repo, poke it to get the updates. Perfect. Let's get started. Let's start with understanding what is the difference between an agent and an assistant when it comes to AI. I'm pretty sure every one of you must have used at least one AI assistant, something like ChatGPT. The primary purpose of these AI assistants is to help you in a conversational style approach. For example, you want to develop a web application and you want to take the help of AI. You cannot go to ChatGPT and ask it to write the complete web application for you because it's not designed to implement a task on your behalf. What you can rather do, you can break your request into multiple pieces. Maybe you can provide initial prompt explaining the context of your request. You want to build a web application in XYZ programming language, and these are the characteristics of your web application. Then in step 2, you can ask it to generate the code for the login page, then maybe for the products page, then maybe for the database connection, then maybe for the CSS, etc. What is your responsibility is to snitch all of these pieces of code or to combine all the pieces of code and build the web application. So overall, because AI assistants cannot implement the tasks independently, you still have a lot of work to do to get your task done. Agents are designed to solve the exact same problem. What agents can do is they can implement the task on your behalf. Not only about web application, it can be EKS cluster creation using Terraform. You cannot expect ChatGPT to generate the complete code for it. It might generate a summary for you and it might generate a high level code. But if you want an entire project taking all the best practices, you need to break that into multiple pieces, and end of the day, you have to snitch them together. But in the previous classes of this playlist, we have seen AI agents like Bowl.new or GitHub Copilot Workspace. They were able to generate web applications like TikTok or even EKS cluster creation within VPC using all the best practices. So this is the capability of agents. In one line, assistants cannot implement the task on your behalf, whereas agents can do that because they can work independent or autonomous. Abhishek, what happens if the agent is stuck somewhere? Some of the agents are also capable of unblocking themselves, or they can create another agent, and they can ask another agent to research how to unblock, and if possible unblock the primary agent. And once it unblocked, it again goes to complete the task. Anyways, we will learn more about complex agents or complex tasks as we proceed through the series. Now the interesting question is, apart from these enterprise platforms, because these platforms are not free to use, is there a way that we can develop our AI agents? Definitely yes. So there are frameworks. For example, there is a framework called AutoGen, or there is something called LangGraph, or even crewai. The advantages of these frameworks: one, they can help you develop AI agents. The second advantage is that they can also work with your local large language models. This is very, very important. For example, in today's video, we will use crewai, where crewai is a framework that can help you get your task done through a single agent or even multiple agents. For example, if your task is complex, so you can use multiple agents where one agent is responsible for a task, another agent is responsible for another task, and you have the final outcome through the framework. The biggest advantage is it can work with the local large language models. Why? Because if you work with, let's say, these enterprise platforms, one, they come with costing. Second, you might also have security implications. Let's say there is a breach in bolt.new, and if your organization is using bolt.new, there might be security implication. Similarly, instead of local large language models, if you go for OpenAI APIs, crewai, which is something that we are going to use in today's video, it can also work with OpenAI, but again, it's the same problem. OpenAI comes with a costing. Roughly, whenever you make a request, it might come to some $0.2. Of course, it depends on input output token. And because you are making requests to the OpenAI servers, it also comes with the security implications, right? So to avoid all of that, you can use crewai. Using crewai, you can develop agents, and these agents talk to the local large language models to execute the task for you. Abhishek, why an agent talks to large language model? Because without a large language model, AI cannot do anything, right? End of the day, whether it's an agent or whether it's an assistant, they need help of large language models because they communicate to the large language models and implement the task for you. Now, what is the task that we are going to do? Of course, we can take the same examples like a web application creation or EKS cluster creation. But what we will do in this video is we will take a beginner level task, that is to research the latest trends in the field of Kubernetes. Because Kubernetes is very vast, let's say your organization wants to research the latest trends in the space of Kubernetes and to write a blog, or maybe to write a MD file which summarizes top 10 important features or maybe top 10 important trends that your organization has to focus. Now, usually this is a task for a senior data engineer, or maybe this is a task for a senior Kubernetes engineer in your organization. We will do this using two AI agents. Of course, we will use Crew. So using crewai, we will use two agents where the first agent will perform research, So it will research the latest trends in Kubernetes. How this agent will research? It will use Llama. We will use Olama, using which we will use Llama. And then the other agent. Okay, so the first agent perform research and second agent summarizes the important points, right? So let's try to do this. It's not at all difficult. We will be doing it in next 10 minutes. And in the next lectures, we will take complex AI agents, or we will try to solve even a bigger problem. Cool. So how do we start with it? Very simple. We should first start with installing crewai. So let me take my terminal. There are some prerequisites. The first prerequisite is that your Python version. Of course, you will find all of that in the document, and also you can check these requirements in the crewai's page, right? So you can also go here, click on open source. They have an enterprise offering and they also have open source offering. Open source offering is very popular. Just click on open source, click on pip install crew, and you have all the steps here. For example, if you go to installation, you will see what are the prerequisites, a specific Python version you need to have, and steps to install. So highlighting the prerequisite, your Python version should be between 3.10 and 3.13. Any other Python version might result in incompatibility issues. So my Python version is 3.12. So I'll first create a directory, mkdir crew example. Let me switch to the directory. And whether it is mentioned in the documentation or not, it is always a best practice to create virtual environments in Python. Because when you're working on different Python projects on your machine, for example, like I do, you will run into dependency issues. Maybe one of your Python projects might use a specific version of dependency. Another Python project might need another version of the dependency. So it will run into package dependency issues. So to avoid that, Python 3 -m venv, let's call it as crew. Okay, so I created a virtual environment called crew. Now I can just go to the virtual environment, source, crew, bin, activate. Now, whatever packages that I install within this virtual environment, once I come out of the virtual environment, I will not have those packages on my machine. Like if I do deactivate, I will come out of the virtual environment and anything that I installed within the crew virtual environment will not be available on my machine, right? So let's go back again, source, crew bin, activate. Now I'll just start with installing crew, pip install crewai. For the first time, it will take time because it has to collect crewai and it has to download a lot of dependencies. So don't worry about it. Okay, so it's installing all the dependency packages, installing collected packages. You can see these are all the packages that it collected, successfully installed. Great. So now once this is done, it should be done in few seconds. Once it is done, what you will do next is you will create a crew using the crewai Python package. And it creates the folder structure for you. For example, right now, if I do ls-ltr, right? So I have nothing in this folder. This is a virtual environment, but otherwise I don't have anything else. So what I will do now is I will run this command crew create crew AI, create crew DevOps AI project. You can put any name for it. So I'll just call it DevOps AI project. And it is going to create all the files that are required. They have simplified this workflow a lot. Previously, when I used it before, they did not have this option. Now, you can interact with all of these LLM providers. For example, OpenAI, Anthropic, Gemini. What I'll do is I will select Olama. Yeah, definitely you need to have Olama on your machine. If not, it's very simple. Just download Olama. Let me select option number as 6. And then it asks to select the model. So I will select 1, Llama 3.1. Why? Why did I select that? Because if I do Olama list, I already have Llama 3.1 running on my machine. We actually use that in day 3 of this playlist, where we created a AI project for DevOps engineers. We use the Llama 3.1. That's why I already have it on my machine. Otherwise, just search for Olama, download Olama according to your OS. And once Olama is downloaded and installed, all that you need to run is Olama pull Llama 3.1 latest. That's the only additional thing that you have to do if you don't have this LLM running on your machine. So it says it has generated all of these files for us. Perfect. So it generated the gitignore file, the project related files, readme file, user preference. But the main files that we need to focus are these configuration files and the Python files. I will take my Visual Studio Code to make it simple. Open new folder, crew, example, DevOps AI project. Okay, so this is the project. The important files are under src. So you have the config files where you have agents.yaml. So these are the two agents. One is the researcher agent and other is reporting analyst agent. So you might ask, Abhishek, how did crew knew that we are going to perform a research related task? Because here you have explained that one of the agent will perform research and other agent will perform on the analysis. We have the exact two agents. The reason for that, crew is very known for research related activities. So by default, it comes up with a researcher and reporting analyst. If you want, you can change them and you can also add more agents. As I told you, we will learn that in the next videos. So for now, I will try to explain you what exactly is this agent configuration, what is the task configuration. So we have two agents here. One is the researcher agent, where the researcher is a senior data researcher. So we are telling the agent to assume itself as a senior data engineer. Topic, it comes from the Python files. We need to update the topic in the Python files. For now, whatever task we are giving, it's a senior data researcher. And the goal of the agent, what did we declare? Uncover cutting edge developments in that particular topic. Let's say the topic is Kubernetes. This AI agent, the researcher agent, will work as a Kubernetes senior data researcher and it will uncover cutting edge developments in Kubernetes. So this is basically a variable. And we also provide them a backstory. You are a seasoned researcher with a knack of uncovering the latest developments in Kubernetes. Known of your ability to find the most relevant information and present in a concise and clear manner. Abhishek, can I change this information? 100%. You can modify it according to your requirement. So this is the first agent in the agent.yaml. What is the second agent? Kubernetes. Because our topic is Kubernetes, it is Kubernetes reporting analyst, where it will create a detailed report on Kubernetes depending upon the analysis and research that it has done, the other agent has done. Similar to the researcher agent, even for the reporting analyst agent, we need to provide a backstory. So now agents have the context. What are we doing in this file? We are basically providing them with the context. Then in the task.yaml, we will tell them about the task. Now they have the context. In the task, we will tell the researcher agent, your task is to conduct a thorough research about Kubernetes. Make sure you find interesting and relevant information given the current year is 2025. The expected output from the researching topic, list a 10 bullet points of the most relevant information and pass it to this particular agent. Now what this agent will do, the reporting agent, the task it will perform, review the context you got and expand each topic. And then create a full-fledged MD file, blog, Excel sheet, whatever you want. Perfect. So crewai makes it extremely easy for you. You don't have to write code. You have to update the context for the agent and also the task it has to do in a YAML file. And it also created the folder structure for us. So we don't even have to bother about creating the config folder, agent YAML file, task YAML file, anything. Now, if you go to main.py, you will only change one thing in the main.py, that is the input section. So what is the topic? Right? So this is the topic. Wherever you have the topic, you can just update that because this topic is sent to the configuration, right? The agents.yaml. So you can just search for topic in the main.py. Wherever you find it, just change that to Kubernetes. If you want to research on Docker, you will just change this to Docker. Or let's say you want to research on something out of DevOps, you will just modify this particular field. That's it. Okay. Rest all are the variables for the topic. Because we changed the actual values, they will be replaced. I'm not touching any other thing. Cool. So now that it is updated, what main.py does is it invokes the functions that are in crew.py. In crew.py, within the class. So this is a Python annotation, or basically this is a decorator. And within the class, you have the agents. So the agent decorators on the definitions means this is the actual task the agent is performing. The researcher agent, reporting analyst agent, and the task. We will not modify anything in this file. Okay. So now we will go ahead. I can take a terminal here also, but I usually prefer this terminal. Making sure I'm in the right folder, DevOps AI project. If I do git status, okay, so the git repository is not initialized. I will initialize it later and push the changes to the repo. I'll just verify the src within the main.py. It's updated to Kubernetes. Great. The first command that I'll run is crewai install. Okay, so crewai install. This is the first command that I need to run. Again, this will take time, right? So because it has to, not only this one, but when you run the run command, because it has to interact with the LLMs. If you are using a machine with CPU architecture, it's going to take a lot of time. So don't worry about that. Great. So it set up everything that is required for this project. When you run crew install, it actually creates this file to track the dependencies, uv.log. You can also open this file and check. Anyways, we will now run crew run, right? So we are done with crew install. So let's proceed with crew AI run. Okay, now this is the actual point where if we go back to the architecture, so now the first agent will interact with the llama because we selected llama as the large language model. So this agent interacts with large language model, perform the task. Then the second agent also interacts with llama and interacts and executes the task. So this particular step might take a lot of time. Be patient and try to see each and every step it is trying to perform. Once it is done, it will generate a report or reports.md file on your machine with the final outcome, right? So this final outcome will be part of the reports.md file. So we have the first task. This is the first task. The status is executing the task in progress, which is the agent that is performing the first task, researcher agent, Kubernetes senior data researcher. And then the Kubernetes reporting analyst, this is performing the other task and it is also in progress. Great. So the task is complete and the crew is also complete. That means basically everything is completed with respect to your task. Let's see if it has the reports.md file. So this is the report.md file. We can basically cat this file because it generated a MD file. It's hard to read on the terminal. What I'll do, I'll just copy it from my terminal. I'll pick up a MD file reader. There are a lot of MD file readers and editors online. So MD file editor, I'll open this one here. Paste. So this is the complete report that is generated. Now, because we can't read MD file properly, I'm using this and this is the preview. Now you can just upload this to your GitHub or you can post this as a blog, whatever you want to do. Agent has researched, agent has created the report where 2025 Kubernetes report. You might ask, Abhishek, why this information is outdated? You must know the answer. The reason why it is outdated because we were using Llama 3.1. Instead of Llama 3.1, if we would have used, let's say, OpenAI, uh, OpenAI APIs, then you would see the latest Kubernetes version as 1.32, right? It's okay. What we want is to see how agents work together, how they switch, how they snitch the information for us and generate such reports. Even when we try to implement coding related tasks in future videos or maybe Terraform or CI/CD pipelines, because we will be using local models just so that costs are not incurred, we will see the outdated information. Okay, so you don't have to worry about that. Abhishek, how can we overcome that? I want to use local models and I want to get updated information. Then instead of Llama 3.1, Crew AI should support Llama 3.3 when I do Llama list. So you can see here, I have 3.2 as well. And the recent one is Llama 3.3. So when they start supporting the recent models and, once we pick up models with more billion parameters, again, the Llama 3.1 that I have is only 4.7 billion parameters. So it is trained on less parameters. So the accuracy of the model is also less. I hope you understand that. And try to implement this project on your behalf. You have everything that is required. I hope you enjoyed today's video. See you all in the next one. Take care. Bye-bye.